Yeah, so like I was saying before I forgot to start the recording, yeah, right now, Linear versus Nonlinear Lab 2 does say that it's due the 5th. I have to go in and change that. It's actually going to be due the 4th because your final opens on the 5th. And there's a couple of reasons for this that I'll get to here in a second. So we will be reviewing for the final Wednesday, November 29th, Thursday, November 30th, and Monday, December 4th. So if you are not in here some of those days, there will be videos posted that you want to check out. All right, and there are already videos from April that are posted in there. Those should be visible to you now if you need to check those out. All right, the question that everybody's been asking, the second redo week. Okay, so the second redo week is going to be from December 4th to Sunday, December 10th. Okay, and I put this in here the way I put it in there on purpose. I'm just going to tell you now, if you don't have it to me by December 10th at 11:59 p.m., you don't have it. Last time with the first redo week turned into the redo 2 weeks. And then it turned into the redo whenever you could get it to me because everybody kept having all these circumstances pop up that prevented them from doing something that they knew about weeks ago. That is not going to happen this time. We had people that abused that. Some people had legitimate things pop up. They did. But other people didn't. They just, were abusing the system. So, regardless of what happens outside of this classroom, outside of this Moodle class, that is out of my control. I don't care if your dog is an arsonist and he burns your house down. If you do not turn it in by December 10th at 11:59 p.m., it will not be counted. Is that clear? There will be no extensions. Okay? I don't care if you have to go get your grandpa out of jail because he stole an ATM. If you do not have it turned in by December 10th at 11:59 p.m., it will not be counted for you. Plain and simple. All right? Don't be sending it to me on December 11th at 12 a.m. or 12:01 a.m. Don't be emailing me at 8 o'clock in the morning on December 11th saying, oh, I forgot about no, you didn't. Because for one, I told you to your face. Two, it's on this video I'm making right now. Three, it's in an announcement, so I don't want to hear it. Because I heard it enough. 2 weeks after fall break. I'm still doing people favors. Not going to happen this time. There is no time. Okay? So, that being said, hold it, Kane. All right. So, again, some people had reasons. Other people had excuses. They will fall on deaf ears this time. Get it in or you don't have it. Plain and simple. The final. All right, let's talk about the final. So, I've already emailed Mr. Forrester and Dr. Chambers to let them know that your last day that you have to be in here is December the 5th. And even still, I'm making that optional for if you want to come in and take your final early. Okay, because that will be the first day that it's open. And I know that not everybody has, internet that is fast as it is here or over at the CCSI. So if you want to come in and take it, that's fine. The lab will be open. You can do that. But then, after December 5th, you don't have to come back. And then even still, you don't even have to come in on that day. I'm just making it available to you in case your internet isn't what you'd like it to be. Yes, King? That's fine. Okay. So, lots of stuff going on in the next couple of days. Again, I will fix the due date on the Linear versus Nonlinear Lab 2 after this class is over and get Linear Labs 1. Linear Lab 1's graded. I've got to put in some late grade overrides for a couple of folks that didn't get them turned in. And so when you come in on Thursday, we are going to be going over everything from the year to help get you ready for the final. Now, you want to make sure that any of the final review videos that I post from the other classes, you want to check those out just on the off chance that there's something in there that was covered that we did not cover in here. Because the way that I do the reviews, you go back and you look through your assignments. You look at the questions that you missed that you still don't really understand why. We put them on the board. You write it down. It's on the video. That's how we review. That's how I've always done reviews any place I've worked at. Okay? Because I'm not going to go back and reteach 14 or 16 weeks worth of material in 50 minutes. I'm good, but I'm not that good. All right? So you come in with, between now and Wednesday, or between the time this class is over and Wednesday, you start going through your assignments. Go back and look at your old grades, any of them that you missed and you're not really sure why. We'll either put it on the board, or if it came from the finance section, we'll put it up on the screen. All right? Okay. Let's close out our regular lessons by looking at Linear Lab 2. If you want some graph paper, there should be some left back there behind JT and Derry. I'm not sure how much of each one is available. I know most folks do things digitally these days anyway, and everybody's better at that than I am. So if you want to pull up a digital copy of one of the graph paper sheets, that is still in Linear Lab 1 towards the bottom, or in that folder that says graph paper options. You can pull it up in like Paint, or if you have Photoshop or whatever, you can pull it up. Whatever kind of screenwriter that you have, you can pull it up and manipulate it that way. I'm going to use the one I used last time. Just got to find it over here. It's a PDF, so it takes it a while to open. Okay, so while that's opening, let me switch gears here for a second. Okay, so let's talk about nonlinear functions. Almost said nonlinear fractions because I can't read, or write for that matter. Okay, so a nonlinear function is really just a function that has enough differences in its slope-intercept form to affect the graph and make it something besides a straight line. Now, we're not going to get into anything like overly complicated, or anything like what you might see in, say, like Math 171 or 172. I'll let Swanson cover that stuff. But two types that we are going to look at today that you're going to see on your lab that we'll talk about. The first one that we're going to talk about, you might remember it if you took some, if you've already had some high-level math classes. So the first one we're going to talk about is quadratic. All right, a quadratic function. Okay. So this, for our purposes, is when your x, oops, I don't know what I was writing there, is when your x has an exponent of 2. Or in other words, if you have something like that, 2x squared minus 1. Okay? This is just an example. I'm going to try to keep the number values in these relatively small just so that they'll fit on the graph. So, you know how we went over and over and over how to take a linear functions equation and just graph it that way? You slap the y-intercept on there, you walk the slope to the second point, draw your line, you're done. Easy peasy. Kind of hard to do that with quadratics. You can do it, but I'm not going to, we don't have time. So what we are going to do is use the easier way and just make a function table. hope this is showing up on the video. Okay. Now, I probably should use the black marker. Works better. So, I haven't uploaded yesterday's video yet because like I said, yesterday was crazy. But when you're making a function table for your nonlinear functions, my advice, pick an x value that's negative, let one of your x values be 0, and then pick an x value that's positive. So, you want to kind of make your first one negative. You want your second one to be 0, and then you want your third one to be positive. Now the reason behind this, mainly for the 0, is so that your y-intercept shows up. The ordered pair for the y-intercept has 0 for x, right? So with these, it helps when you can see where the y-intercept is. And then as far as like your negative and positive values, realistically, you can pick whatever you want. Just be very careful with these because, like yesterday, for instance, I forgot what it was I put on the board, but I think because I had a y-intercept of like 5 with a certain x a student picked, we got a y value of negative 52. It'll work. You can make it work, but you have to change the scale of your graph paper. So I will try to keep the values small. So what we're going to do, pick a negative and positive x for your table, okay? So show where you substituted it, and then get your y's. Okay, everybody go ahead and do that now on your own, and then we will check them, and then we will graph them. We'll get there, Kane. All right. Who's still getting your table filled in? Tell you what, we'll give you another minute. One of them days. All right, everybody about got it? Anybody still getting it finished up? All right. So somebody tell me what negative x value you use. I heard -2 first. All right, and then how about your positive one? 3. Okay, that'll work. All right, so you just substitute these in. So you'll have y equals 2 times -2 squared minus 1. So then you just fall back on your rules for order of operations, for multiplying exponents, and so on. So -2 squared comes out to be what? Well, just the -2 squared part. Right. -2 squared comes out to be 4. And then 4 times 2, 8. Then 8 minus 1, 7. Yeah. There we go. I know some of you already had it, so that's fine. 0, well, we all know what 0 does. Basically wipes out the slope, and you're just left with the y-intercept. So negative 1. And then we'll do 3. So y equals 2 times 3 squared minus 1. 3 squared, 9. 9 times 2, 18 minus 1, 17. You can tell I've been helping my daughter with her math homework. Yep, ongoing battle. All right, so anyway, let's plot these points. So we've got, blue, negative 2, 7. So before we mark this, that 17 is causing a little bit of a traffic jam here, because I think these only go up to 12. Let's see, 5, 10, 12. Yeah. So what we may have to do is we could go up by 2s. Oh, that should work. Yeah, like 2, 4, 6, 8, 10, 12. Yeah, that'll work. We'll count by 2s. All right. So I'm going to change the scale of this a little bit. So 2, 4, 6, 8, 10, 12, 14, 16, 18. That's far enough. All right. So we're just counting by 2s, just so you know. All right. So our first one, negative 2, 7. Okay. Well, negative 2 is going to be right here. And then 7 up is going to put it halfway between 6 and 8. Right there. All right. Where is the... There it is. Okay. Next one. 0, negative 1. All right. Well, 0 is right here. This point right here is negative 2 on your first block down. So 0, negative 1 is going to be right there. And then 3, 17. So 3, it'll be halfway between 2 and 4. 17 will be halfway between 16 and 18. So it's going to be floating in an empty block there. All right. So yeah. Y'all were so close. Yeah. So if you have a positive slope, it opens up. And if you have a negative slope, it opens down. All right. The negative 1, all that's going to affect, the negative or positive 1, all that's going to affect is if it's down here or up here. It's called I think it's called a shift. The slope, if it's positive, it opens up. If it's negative, it opens down. All right. So if you're copying these graphs down or if you're doing them digitally, everybody got it copied? Anybody still need to get it real quick? If you need to get a picture of it, yep, make sure you zoom in pretty good. Those numbers are kind of hard to see. All right, everybody got it? All right, so let me hop over to stuff that I've got in Moodle just for a second. Then we'll hop back to the graph. Okay. All right, so, yeah, quadratic functions. When graphed, the result is a parabola, a U-shaped curve. A parabola can open upward or downward. Now, because our slope was 2, it was pretty steep, wasn't it? If you had made something like 1/2, though, it would widen out, right? It would be more bowl-shaped instead of like a funnel. But yeah, what causes it to flip is the slope. All right? Good deal. We'll look at a couple more in a minute, but any questions about the quadratic? Remember, the exponent is on the x. All right? So let's do another one that's different. Uh-oh, I didn't mean to erase that. Put that back. All right. I don't know why I wrote a 2 there. I must be losing my mind. All right. So the second one that we're going to look at is absolute value. Okay. So does everybody remember what the definition, or I guess I should say, does anybody remember what the definition of absolute value is? Kane? All right. And Lily, tell me, can distance ever be negative? No, distance cannot be negative. I used to use this example several years ago. You're waiting on the bus at your house, all right? Your front porch stoop is 10 feet from where the bus stops. You walk 10 feet to the bus, realize you forgot your backpack, you have to go back to the house, then get back on the bus. How many feet did you travel? 30. Yeah, you don't subtract the 10 feet that you went back to the house from your distance, right? So I had a math workshop several years ago that was put up by somebody within, well, we'll say one of the county schools that is not too far away, that tried to tell us all that distance was negative. Me and 3 other math teachers like shot our hands up. We're like, no, it can't. And the whole room got really, really uncomfortable. You know, it's almost like, 2 brothers just slapped each other at the dinner table and we're all trying to eat still. It was very, very weird. But yes, absolute value is your distance from zero. And distance cannot be negative. That's why a lot of folks used to associate absolute value as the make it positive bars, or, I've heard all kinds of things. Some people get it misconstrued, though, and think that it just takes the opposite sign of whatever's in there. Not the case. You don't put a positive number in there and then make it negative when you get done with it. That's not how it works. All right? So, an example for this one that we'll do. Let's say y is equal to 1/2 of the absolute value of x plus, let's keep it short, plus 1. All right? So go ahead and make your table. Remember my advice. Make your first one negative, make your second one 0, and then make your third one positive. Let's give you, let's say, 2 minutes. All right, a couple of people still working. Got about a minute. All right. So, someone tell me what negative x they used. Negative 2. And then somebody tell me what positive x they used. 4. Okay. All right, substitute. So the first one, we got y equals 1/2 times the absolute value of negative 2 plus 1. Now, absolute value, those fall into our grouping symbols. So as far as order of operations, you want to take care of that first. Well, the absolute value of negative 2 is 2. 1/2 of 2 is 1 plus 1 is 2. There we go. All right, 0, well, that's just going to be plus 1, all right, or positive 1. We don't really need to go through all that. And then 4. So y equals the absolute value, nope, I forgot the 1/2. Y equals 1/2 of the absolute value of 4 plus 1. All right, it would be 3, yeah. 4, half of 4 is 2, plus 1 is 3, yep. Good job recognizing that since it's 1/2, to make it easier on yourself, that you might want to pick even numbers. Good job. All right, so let's get it graphed. Slope rule still apply. If it's positive, it flips up. If it's negative, it flips down. Okay? The reason why it's straighter than a parabola. Parabolas are growing at an exponential rate. Exponential rates are always curved, right? Because they eventually get to where the exponential change is so little that it looks like a curve, because half is still like way, 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 way down. And then, of course, if you have an exponent see here that -1 and +1 both share a force for their y value. So it's going to curve, right? And when you graph it, it makes this graph. Okay? So really, if you just use the -1, 0, and +1, that's, this region right here. You don't really need those up there. Now, so you see the parabola curves because its growth rate is exponential, meaning that with each new x, it's jumping further and further and further up the y-axis. Whereas with a absolute value graph, the reason why it's straighter is because it's linear on one side and the other side. But if it's split into two different graphs, then that's called a system. Yeah, so we had negative absolute value of x minus 2. So in other words, -1 times absolute value of x. So they use -5, -3, 0, +3, and +5. Again, if they had just used this section here, they would have been fine. Okay? -3, 0, and 3. Because look, -3 and +3 have the same y value, right? So because of that, you get a graph like this. Again, negative absolute value of x. It was negative, it flipped over. All right? And again, notice that the change between the y values is more constant. It's just with absolute value, they share the y-intercept. They don't go past it. It flips around because negative and positive absolute values both have the same distance. So on the assignment, again, I know that the assignment says they are due December 5th. I have to go change that because that's incorrect. They're really going to be due on the 4th. There is a work entry. There are a lot of questions on this one this time because back in the spring, this was all one assignment. All right, this had everything that we talked about in Linear Lab 1 and the new stuff. That's why there's 20 of them. Okay? There is a student copy that you can look at. It's all the way up here above the pictures. Right there. Something to look out for. Okay? 20 questions. All right? There's 20 about, there's 25. There's 20 about the linear functions, 5 about nonlinear. Okay? There are mostly type in the blank questions with some multiple choice as well. Mainly because I sort of henpeck questions from all the books that I have and put them in there, and the questions from those books were non-multiple choice, and I wasn't about to, so just, they're typing. There should be an acceptable margin of error within there. Okay, use common sense when you're typing this stuff in. If you're going to type in a -5, for instance, don't type in -5. Don't hit space bar first either. Okay, it's probably going to kick it out. You got to be careful with typing the blank. No unnecessary spaces. Like I said, don't put any at the beginning of your answer or it's not going to be counted. It says the 5th. It should be due. I'm going to fix it as soon as we get done here. They're not due the 5th. They're due the 4th. All right, I'll get it fixed. All right, and again, just to recap for the video purposes, since I fried it with my cell phone at the beginning of the class. Again, make sure that you know what important dates are coming up. Okay? Again, I cannot stress enough, the redo week. All right? I do not want to hear your excuses. You either turn it in or you don't. And that's mostly for the video folks, because they are notorious for sending me all kinds of, things that happen. All right, so save yourself and me the time to take to send that message. All right, any message that you send me wanting something to open up. All right, a couple of things. Something I did forget to mention at the beginning of the class. 1, when does it say the redo week starts? The 4th. Should I get any messages from anybody before the 4th wanting stuff open back up? No. Because what am I going to say? No, redo week hasn't started yet. That's the reason why I signed the time slot. Also, even though I told people to their faces, either face-to-face right now or face-to-video, when you request a redo, you have to be specific, whether it's the work or the entering. And a lot of people did that. A lot of people did exactly what they're supposed to do. That's great. There's still that select few that just would send me a message that says, I knew a percent lab open back up. And I'm like, what part? And I never heard that. So you can tell me y'all are pretty good about that. Most of the culprits, like I said, are in something online. Okay, we'll see you again on Thursday. Thursday for you guys, WLM1 will be your last in-person class unless you come on the 5th to work on your file. All right, have a good day.